What's up, kids? It's Mr. Murray here, Mr. Murray's Mathland, and today we're starting some trigonometry videos. And a big part of trigonometry at this level, Algebra 2, pre-calculus, and beyond, is being comfortable with angles measured in radians as compared to degrees. When you get to calculus, it's almost all in radians, and that's because it makes a lot of conversion formulas easier, and for a number of other reasons. But for right now, all you need to accept is that it's a different way of measuring an angle. Just like you can measure height in inches or centimeters, right? So there is just a formula to convert degrees to radians and vice versa. But hopefully you understand a little bit where it comes from, and that's what I'm going for here today. So bear with me with a little bit of explanation of where it comes from and why they're called radians, not something else. So if you have a circle with a given radius, that's what we got here on the left. One thing, first I may extend it to the other side, and that makes a diameter. And I'm splitting the circle into two semicircles, 180 degrees each. Okay, so the idea of a radian is this, that if you have a particular radius in a circle, and you say, if I were to wrap that radius around this circle and say, I'm eyeballing it here, but maybe that curved length, that curved arc length right there is about the same length as this radius, then that central angle would be considered 1 radian. If the distance, the length of that arc is equal to the radius, then this angle here is considered 1 radian. Now, in terms of how many degrees that angle might be, it's certainly something acute. Yeah, it's maybe roughly 60 degrees. It's actually a little bit less than 60 degrees, and we'll talk about why by the end of the video. But for right now, hopefully you can at least sort of visualize what I'm talking about there. And the next question is, of course, well, how many, if I keep going, how many radii can I fit on a particular circle? How many arc lengths of that radius length? And so if I just keep going, again, it's just eyeballing it here, but keeping in mind that what I said, it's a little bit less than 60 degrees. Well, okay, maybe there's about another radius worth here. And so that central angle, if I put those two together, that would be 2 radians, because it intercepts 2 arcs, 2 radii, or a length of 2 radii. If I keep going here, how many? I fit another one there, roughly. And I said it is a little bit less than 60 degrees, so you would expect I could fit 3 and a little bit in this 180 degree semicircle. So there's 3 radii worth. If I keep going around the circle, how many can I fit? And some of you are probably way ahead of me on this here, but there's 4. Here's maybe a 5th. So I'm up to 5 radians total. And so I'm just trying to pick a different color here for this last one. It's going to be about 6. And there's going to be a little bit left over, which should make sense if you remember in the semicircle that was 3 and a little bit. So all the way around the circle, you double that. That's going to be 6 and a little bit. But if you think about it, when I start talking about the distance around the circle, I'm really talking about the circumference, right? That's just another word for perimeter of a circle. And what's the formula for circumference? Pi times diameter, or diameter is just 2 radii, 2 pi r. And you're literally saying the distance around any circle is 2 pi times whatever that radius is. And since pi is 3.14, you're really saying around any circle, 2 times 3.14 is 6.28 radii, or we would say that that whole circle is 6.28 radians approximately, right? So 2 pi radians is 360 degrees. That's 360 degrees around the circle, and that's 6.28 radians, or 2 pi radians. And more importantly, here on the left, 180 degrees is half of that, or pi radians. So that right there is the key to all these conversion formulas you're going to be using here. And you're going to be doing a lot of work with fractions. So hopefully you're comfortable, but if not, I guarantee you'll get more comfortable the more you work with these things. So converting 60 degrees into radians, you're really just saying, if you know this, that 180 degrees is pi radians, just think to yourself, well, what fraction of 180 is 60? And that's a pretty easy formula, right? 60 out of 180 is 1/3. And so you're really just talking that this is 1/3 of pi. So I really just put it over 180 and multiply by pi. It's 1/3 of pi, or as we call it, pi over 3. And if you've done some trigonometry work before, then you should know that's kind of a familiar value that comes up a lot. Pi over 3, pi over 6 is another one, pi over 4. Those are the kind of common denominators you get a lot. 210 degrees, hey, that's more than 180 degrees. So my answer should be more than 1 pi. How much more? Well, to get that exact fraction, you just put it over 180. What fraction of 180 is it? And therefore, it's that fraction of pi. So very easily, you divide by 10, the zeros cancel. And then 21 over 18 reduces to 7/6. So it's 7/6 of pi, or 7 pi over 6. So you see, all I've really done here for these couple problems is to convert from degrees to radians. You just multiply by pi over 180. That's what I've done in the two problems so far. I put it over 180 and multiply by pi, slap a pi on it. So 320 degrees. 320 is what fraction of 180? And multiply by pi. Again, we get that nice zeros canceling, divided by 10, and 32 over 18 is going to reduce to 16 over 9 pi. So 16 pi over 9, right? So very easy to work with, right? Multiply by pi over 180, and hopefully you kind of understand why. So if you do forget which way you're going, you can maybe reason it out. Because now when we go the other way around, when we go from radians to degrees, just think about it here. The first one, 5 pi over 6. Now, you want to see that almost as 5/6 of pi. That's 5/6 of pi. And what is pi? Radians in terms of degrees? Pi is 180 degrees. Again, that's that key fact that I'm kind of basing all this on. So this would just be 5/6 of 180 degrees. And yes, working with fractions, that means you could multiply by 5 and then divide by 6, but be smart. See if you can divide first, always, right? 6 goes into 180 30 times, so 5 times 30 is 150. And that should make sense, right? Because pi is 180, so 5/6 is a little bit less than 1, so we get a little bit less than 180 as our final answer. Seems good, seems pretty logical, because all I really did was my formula in reverse, right? Instead of multiplying by pi over 180, we're dividing by pi over 180, which means we are multiplying by 180 over pi, the reciprocal. That's all I really did here, is I multiplied by 180 over pi. The pi's cancel, and the pi was essentially replaced with 180. So in part B, 11/20, that's 11/20 is a little bit more than half, so I should be getting something that's a little bit more than half of pi. And what is pi? It's 180 degrees, right? That's all I did was I multiplied by 180 over pi. The pi's canceled, replaced by 180. And what's 11/20 of 180? 20 goes into 180 9 times, so 11 times 9 is 99 degrees. Notice a little bit more than half of 180, right? 11/20 of pi. And so you get an answer that's a little bit more than half of 180. Half of 180 is 90. Pretty logical, hopefully. And part C, 4 radians. Notice that not 4 pi, not every radian value, has a pi in it, right? Like even the explanation at the very beginning of what 1 radian was, that's 1 radian, not 1 pi. Pi is just the number 3.14 approximately. So don't get hung up on that and think a radian value always has pi written in it. So this is where you might have to trust your formula a little bit more to convert 4 radians into a degree amount when there's no pi to simply replace. So when you do 4 times 180 over pi, the pi does not cancel. So you simply get 720, that's 4 times 180, over pi degrees. And that doesn't reduce or simplify, that's an irrational number. If you want to get an approximation for that on your calculator, 720 divided by pi is about 229 degrees. And hopefully that kind of makes sense, because if you think about that explanation we did of, when you draw a circle, getting 4 radii worth, right? That was 1, 2, 3, and the 4th, it took about here, and that's about 229 degrees, right? Going past 180 to about there. So that's what you're dealing with there. And at the very beginning, I said, 1 radian is approximately 57 degrees. And that's how you could really convince yourself is 1 radian multiplied by 180 over pi. And you simply get 180 over pi degrees. And that is approximately 57 degrees. So that's what 1 radian is actually worth, a little bit less than 60 degrees. So there you go, kids. There's a few examples of converting in each direction, but more importantly, hopefully you understand why somewhat and have a better appreciation that it's not just some arbitrary formula to memorize. It's something tangible that you can hopefully understand. So keep working hard with it. Hang in there. If you're a little confused by them still, you're going to be working with them for a long time, and I promise you it'll get better. So keep working hard. You got any questions? Let me know.